Module 4, Lesson 28, two-step problems, all operations. So we're going to be working with add, subtract, multiply, and divide, and we're going to be having two operations. Well, not two operations per se, but two steps, two things that we need to do to solve instead of one step. So we are using substitution to determine whether a given value makes an equation true, and we are going to write and solve equations involving real-world problems. So I can solve two-step equations by using order of operations, the properties of operations, and tape diagrams. And I can use substitution to determine if my solution makes the equation true. Juan has gained 20 pounds since last year. He now weighs 120 pounds. Rashad is 15 pounds heavier than Diego. If Rashad and Juan weighed the same amount last year, how much does Diego weigh? Let J represent Juan's weight last year in pounds, and let D represent Diego's weight in pounds. So here we have a real-life situation, and we're going to have to do two steps to find the answer to this question. And right now you're probably feeling a little bit overwhelmed. This is why we're going to talk through a strategy here. We're going to talk about taking it one step at a time. So the first thing we're going to do is we're going to say, what tape diagram can we draw to represent Juan's weight? And I have drawn a tape diagram that has two parts on it. Now the reason for that is that it says I have Juan's weight this year, but I also know that there has been 20-pound change since last year. So the entire tape for Juan is 120, but this little piece here is 20 because we had a change from last year. So that's what I would draw for Juan. So I have looked very carefully at information that I have about Juan, and I have said, how can I represent that? Now it says that I'm supposed to draw a tape diagram to represent Rashad's weight. Now it says that Rashad is 15 pounds heavier than Diego, and it says that Rashad and Juan weighed the same amount last year. So I know that Rashad and Juan weighed the same last year. So I have a tape that's the same size. But I also know that he is going to be heavier than Diego, so there's going to be two parts here. All of what Rashad was last year, but we also have his comparison or difference with Diego. So I've got two parts here. This is where Rashad was last year, but this is the difference with Diego, which leaves us with Diego, and we just talked about him. So Diego is this piece right here, because he has a difference of 15 when compared with Diego. So now we can slowly work our way through this and unpack this. Well, we know that, and I already drew this, we know that at the moment Juan is at 120, and we know that this is 20. So we know that this is 100. We know that there's a difference of 15 between Diego and Rashad. So this is 100, take away the 15, and I'm at 85. So now there's all my numbers to represent what's happening here. So what connections, and so there's all the numbers, because of course that's what everybody's worried about in math. But now let's actually go back through and look at it without the connections in numbers. Let's take a look and just say, what connections do we have? Well, we know that this is Diego, and we know that this is Diego, and we know that this is 15. So we know that this is Diego plus 15, and we know that this is 20. So the connections that I see in these tape diagrams are that this is equal to this. So instead of calling this R plus 15, Rashad plus 15, I'm going to call this Diego plus 15. So I can express this entire problem using, instead of 3 variables, 1 variable. Now, another way of looking at this problem is to say that I've got the 20 here, the 15 here. These are numbers. These are constants. They're not changing. They're locked in. But I know that this is Juan minus 20, and I know that that's going to be equal to Rashad. And this is Rashad taking away 15. And this is Diego. Now, looking at it this way, there are some small connections. I mean, here's Rashad and here's R. But I don't see the great connections that I get when I start at the bottom and say, okay, this is Diego. And that means this piece is Diego, and I know that this is 15 because it's a constant. And then this is Diego plus 15, and I know that this is 20. So could we combine all of these to make one tape diagram? Well, yes, we could. Because I know that this is Diego, and I know that this is 15, and I know that this is 20. And I know that this top right here, that this is Juan. Juan is equal to Diego plus 15 plus 20. So now all of a sudden, I have this algebraic expression that is showing the relationship between Juan and Diego. And I already wrote the equation. So Diego is equal to, Diego plus 20 plus 15, and of course that's 35. Diego plus 35 is equal to 1, which is 120. And then I can use my identity properties. D plus 35 minus 35, which will leave me with Diego. And over here I've got 120 minus 35. Do a little subtraction here. And I find that Diego is 85 pounds, which, if you'll remember, is what I figured out just putting the numbers on the tape diagram. I had the 120, and this was 20, and this was 100, which meant that this was 15, and this was 85, and this was 85, so this is 85 plus 15 plus 20. So walking through, there we go. So now the question, does our answer make sense? How can I check? Well, I would do some substitution, right? If I say that Diego is 85, and this is equal to Diego, Diego plus 15 gives me Rashad at 90. So Diego's 85, Rashad is at 90. I've got 90 plus 20. Oh, my goodness. 90. Where did I get 90? 85, 15. This is 100. There we go. That's better. 100 plus 120. So I have just checked by substituting. If I put Diego's in here, and that's 85, and Diego's in here and add it together, I get Rashad at 90. Ooh, at 100. Boy, I'm really struggling there. And then I've got 100 plus 120, so Juan is equal to 120. So my equation, Juan is equal to Diego plus 15 plus 20. Juan is equal to Diego plus 35. And if I say Diego is 85 plus 35, I've got Juan is 120. So what we're looking at here is relationships. Really looking at relationships and how do these relationships transfer across tape diagrams. So the last couple of lessons we've really tried to look at that. Well, this is equal to this and then this is equal to this. That's what we're using here. So the first thing we want, well, let's read the question. Marissa has twice as much money as Frank. Christina has $20 more than Marissa. If Christina has $100, how much money does Frank have? Now, one of the things I like to tell the kids in class is to think about who has the least out of all of this. So Christina is more than Marissa. And Marissa has twice as much money as Frank. I like to think of it as using Legos, and we start with our small building blocks and then we build upward to the bigger situation. So we're going to draw a tape diagram for Frank. Frank has the least. Now the next thing is that Marissa is the next person on the list. She has more than Frank. How much more? Twice as much. So I'm going to double what Frank has. So if I've got one box for Frank, I need two for Marissa. And it's double, twice as much. So there are two of them that are the same size. Now it says Christina, who has the most, has 20 more than Marissa. So Christina has everything that Marissa has plus an additional 20. So I'm going to draw these two plus another little box on the side here so that I can add 20 on for Christina. So here are my two for Marissa plus the 20 more that Christina has. Now it says Christina's got 100. So I'm going to work on the tape diagram with Christina. Christina's got 100. And this is 20 right here. Now all of this is Marissa. And when I look at Marissa's is made with double of Frank. So I've got Frank, Frank, and Frank, and Frank again. So Frank keeps showing up in all of these tape diagrams because he's the smallest building block. So I can actually look at Christina's and say that Christina's amount of money is double Frank plus 20. Now that's kind of handy because now I have a nice little simple equation here that I can solve to find out how much money Frank has. But I can also use my tape diagrams to look my way through this. Well, here's the $20 that Christina has more than Marissa, and I can see that if I have $100 and I take off 20, that Marissa is going to equal 80. And I've got Frank here, so Marissa's 80, and Frank is half of Marissa. So I start to find out 80 divided by 2, and I find out that Frank has a value of 40. He's got $40. And I have just all of a sudden filled up my entire tape diagram. So Frank has got $40, Marissa has $80, Christina has $100. And I figured all that out with a tape diagram. But we also looked at it algebraically. We said 2 of Frank plus 20 is equal to the $100 that Christina has. And we found that right down here at the bottom because these two squares are Marissa and half of Marissa is what Frank is. So I can take that 20 off, do some identity stuff here. So 2 times Frank, if I subtract the 20, then I've just got 2 times Frank. Subtract the 20 here and I've got 80. And I've got 2 times Frank divided by 2, which leaves me with Frank. And I've got 80 divided by 2, which leaves me with 40. So there it is algebraically. So once again, the big idea here is we're looking at what is the connection. Instead of just looking at a connection between two tape diagrams, which is what we did in the last lesson, now we're adding in a third tape diagram and saying how do all three of these work together. Let's see here. And we have been through all of this, so don't stress that that I'm going through these, because we have looked at all of these. I just did them all in one slide instead of separate slides. Okay, so in class we have practice stations for you to practice. So what you'd do is you'd move around the classroom and you'd stop at a station, you'd try and solve the problem. You might leave a piece of paper there so other people can see how you solved it, but we would move around to solve these. Well, that's not really an option where we're doing this online. So what I would ask you to do is pause the video, solve station 1, and then compare with what I do. And then go on to station 2, pause it, solve it, compare to what I do. So instead of just watching me solve them, go ahead and try each one of these. So here we go. It says use tape diagrams to solve. Raina is twice as old as Madeline, and Laura is 10 years older than Raina. So the youngest person that I have here is Madeline. So she's going to get the start of my tape diagram. And Raina is twice as old as Madeline, so I'm going to do 2 squares for Madeline. And it says that Laura is 10 years older than Raina. So I've got Madeline, Raina, and then my oldest is Laura. And she's got everything that Madeline's got, and we're going to add on 10 more years. So this right here is equal to Raina, and Raina is double Madeline. So I can actually look and say that Laura is equal to double Madeline plus 10. It says here that Laura is 50. Okay, so if I take off the 10, that means I've got the Raina is equal to 40. So Laura equals 50 here. Raina is going to be 40, and Madeline is half of that 40 at 20. So then I can check and make sure that everything fits here. So if this is 20, that's good. If this is 20 and this is 20, then Raina's 40. And if this all together is 40 and I add 10, then I've got 50 for Laura. And then I can also check it algebraically over here. 50 is equal to double Madeline plus 10. And I can use my identity to subtract 10 and subtract 10. And I've got 40 is equal to double of Madeline. So I can divide by 2 and divide by 2, and I've got 20 is equal to Madeline. And then I could go back and check it, which I've already done over here by substituting in 20 everywhere Madeline is. All right, station 2. Once again, this is the perfect time to pause, read the question, give it a try yourself, and see how it goes from there, rather than just watching me solve them all. Okay, Carly has 90 apps on her phone. Braylon has half the amount of apps as Theus. If Carly has 3 times the amount as Theus, how many apps does Braylon have? Well, let's see. So I've got Carly. Carly is more than Theus, and Theus is more than Braylon. So my smallest is Braylon, and Braylon is a little bit less than Theus, who's a little bit less than Carly. So Braylon is going to be my first building block. And Braylon is half of Theus, so I need to double that up here. So I've got Theus, which is equal to double of Braylon. Carly has 3 times what Theus does. So everything Theus has, but we're going to triple it. So I need, wow, 1, 2, 3. So Carly is 3 times what Theus is, which means that Carly is 6 times what Braylon is, because Braylon has 2 in each one of these. So Carly is 6 of Braylon. Wow. And I also know that Carly's got 90. So Carly is 90, and that is equal to 6 of Braylon. Wow. All right. Well, I can also use my tape diagram over here. I've got 90, and it's going to split into 6 parts. So each one of them is going to be 15. And each one of those is going to be 30. So this is 30 for Theus. And Braylon is half of that at 15. So there I've got all my beautiful units all lined up, and I can see everything happening. I can check it algebraically. I can divide by 6 and divide by 6 and find out that 15 is equal to Braylon. But I really love the tape diagram. There's such great math thinking involved here about the relationships, recognizing that if Braylon is half of Theus, and here we have Carly that's going to have 6 of Braylon, that I can use that information. So Braylon is 15, Theus is 30, and Carly is 90. All right, looking at station 3, once again, pause. Give yourself a chance to try these. I know the first time through is a little bit tricky or whatever, but there are lots of stations here. Stop and think about them. So Reggie ran for 180 yards during the last football game, which is 40 more than his previous personal best. Monty ran 50 more yards than Adrian during the same game. If Monty ran the same amount of yards Reggie ran in one game for his previous personal best, how many yards did Adrian run? So I've got 3 things going on here. I've got Reggie's new best, and then I've got Reggie's old best, and then I've got Adrian's. Let's see, I've got Reggie, Monty, and Adrian. Okay, let me think here. So I've got Reggie, Monty, Adrian, but for Reggie I've got his new personal best and his old personal best. Okay. Reggie ran for 180 yards during the last football game. That's 40 more than his previous personal best. So we've got his, I'm going to use an N for Reggie's new personal best, which is going to be greater than his old personal best, which I'll use an L for. Monty ran 50 more yards than Adrian during the same game. So Monty's is going to be more than Adrian's. But Monty's is also equal to the old personal best. So Monty is equal to the old personal best. I'm going to replace my old with Monty there, who is going to be greater than Adrian. All right, so we've got Adrian here is going to be my small building block. And I know that Monty ran 50 more than Adrian. So Monty ran everything Adrian ran, but then he ran 50 more. So I've got Adrian, and here's everything Adrian ran, and then we add 50 more for Monty. Now, Reggie had everything that Monty had, but he has increased his personal best by 40. So he's got everything Monty's got, but he's added 40 more on to increase his personal best. So I've still got Adrian here, and I've still got 50 here, and this is equal to Monty there. So I can see that Reggie is equal to Adrian plus 90. And I can see that Reggie is also equal to everything Monty is plus 40, because this is Monty here, and if I add 40 more, then I get to Reggie. I know the total for Reggie is 180. So all of this together is 180. So I can start taking this apart here. 180, take away the 40, and I've got Monty at 140, which is 50 more than Adrian's best. So if I take 140 and I remove the 50, I've got Adrian at 90, and I've got Reggie at 180. And I can also check it algebraically. Reggie is equal to Adrian plus 90. So subtract the 90. Of course, Reggie is 180, we know that, minus 90. So I've got 90 is equal to Adrian, which matches my tape diagram over here. I can check that by saying Monty is 50 more than Adrian. So I can take Adrian, add 50, and I've got Monty, which matches 140 there. And I can see that Reggie increased his personal best by 40, but his old personal best was equal to Monty. So 140 and 40 is 180. Okay, Lance rides his bike downhill at a pace of 60 miles per hour. When Lance is riding uphill, he rides 8 miles per hour slower than on flat roads. If Lance's downhill speed is 4 times faster than his flat road speed, how fast does he travel uphill? We're going to use F to represent his pace on flat roads in miles per hour and U to represent his pace uphill. So let's see. His downhill is 60, and that's going to be greater than his flat, which is going to be greater than on the flat, because it says he's slower uphill than he is on the flat roads. Oop. Flat, which is greater than the uphill. So my building block here is going to be my uphill. Okay. And let's see, it says he is 8 miles per hour slower than on flat roads. So his flat roads are going to be everything he's got going uphill, but he's also got 8 miles an hour more. So that's on the flats. And it says his downhill is 4 times faster than his flat roads. So his downhill has got everything that the flat has, but we're going to multiply it times 4. So I've got all of these 8s here, and then I've got all of these uphill speeds. And that's going to be equal to his downhill speed. And all of that together is going to be 60 miles an hour. So looking at this, I've got 4 8s, and I've got 4 of the uphills. And that's going to equal his downhill speed, which it says is 60 miles an hour. Ooh, 4 times 8 is 32, plus 4 times the uphill speed, altogether is going to be 60. So I can subtract the 32, and I've got 4 times the uphill speed is equal to 28, and the uphill speed is equal to 7 miles per hour. Now, over here on the left-hand side, this is doing it algebraically. Let's just look at the tape diagram that I've got here. I had 60, and I'm going to take out the 8, and that's going to leave me with 52. Take out another 8, and that's going to leave me at 44. Take out another 8, and that's going to leave me at 32, 36, and take out my last 8. 36 minus 8 is going to leave me at 28. So I've got 4 u's. Each one of them is an equal part of 28. 28 divided by 4, which is going to leave me with 7. So the uphill is 7. The flats are 8 more than the uphill, so they're 15. And the downhill, we already know, is 60. All right, so how do tape diagrams help you create the expressions and equations that you use to solve the problems? The tape diagrams help us see the connection between the different parts of the problems. This is this more than this. This is double this. This is triple this. This is half of this. The tape diagrams let us see what's happening. It takes all of these numbers that are kind of just running around in these problems, and they help us see the connections. It is truly overwhelming to read questions like this, but if we take a minute, take a breath, and then start asking ourselves, what do I know? We can think our way through the problem. All right, looking at the learning target here, I can use substitution to determine whether a given value makes an equation true. We were using substitution and checking out our answers a whole bunch of different ways. We can write and solve equations involving real-world problems. I think these slides are a little out of order, but it'll be okay. So here's the I can statement. I can solve two-step equations by using order of operations and the properties of operations and tape diagrams. We used all of this as we worked today. And then we used substitution. We found answers, we put them back into our equations, back into our tape diagrams, and asked if everything made sense. So that concludes Module 4, 28. If you've got things that you're feeling a little stuck on, maybe go back and rewatch parts of the video. If you've got questions, make sure you reach out to your teacher and ask them. Make sure you do your problem set and your exercises.